quick review here at the beginning. So remember how we talked about the 6 can divide into 24 4 times, and the 6 can divide into 18 3 times. So that's just x to the 4c cubed. This one's just x. 2 goes into 12 6 times. 2 goes into 7 3 times with 1 y left over, and 2 goes into 10 5 times. So this one's just x to the 6 y squared z to the 5th root y. And last but not least, this is, or two more, this is just x, y to the 4th. 3 goes into 3 once, 3 goes into 12 4 times. And last but not least here, this is 5 goes into 10 twice. 5 goes into 18 3 times, and the 5th root of here. So 5 goes into 18 3 times with a remainder of 3. Okay, so x squared y cubed, 5th root of y cubed. All right, so that's just review there. There is the property that I skipped, or the part that I skipped in the notes, does say if you have an even power, even index and even power, and you get an odd result, technically you have to put an absolute value on that. But that comes up so rare that we're going to skip that. But just to be precise, this would have to be even, odd. We call this even, odd. Okay, so even, and then you get this odd result. Technically, this has to have protect it to make sure it's a positive. It has to have absolute values. I did not pick any MathXLs that had that, so that's just so I'm covering my math base there, but don't worry too much about that. You'll probably never see it again in your entire lifetime. Okay, property of radicals. If the nth root of a and the nth root of b are real numbers, then multiplication is super friendly. If it's inside the radical, you multiply, if it's inside the radical, you can multiply with something else that's inside the radical. So this is a times b. It's the nth root of a times b. So I always say inside with inside, outside with outside. You can multiply what's inside the radical with what's inside the radical, and the coefficients with the coefficients. Okay, so that's multiplying. All right, so here this is a 5th root. That's good. And so I can do 16 inside with inside. There's no outside coefficients here, so this is just inside with inside. 32 there. And then I have a total of 12 x's. And then we just go to simplify. So the 5th root of 32 is 2. And then 5 goes into 12 twice with a remainder of 2. Okay, that's it. Pretty simple. Number 6, 4th roots. 4th root of 8 times 8 is 64. X to the 4th and y to the 6th. So 8 times 8 is 64. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So the 4th root of 64, be careful here. Okay, remember our fourths powers are 1 times 1 times 1 times 1, 2 times 2 times 2 times 2, 3 times 3 times 3 times 3. So, we want to focus on that 16. I'm sorry, you can't see that. Gosh, okay. There we go. So, your fourth powers are 1 times 1 times 1 times 1, 2 times 2 times 2 times 2, 3 times 3 times 3 times 3, etc. And so you want to make sure the 64, don't jump the gun and say 2 or 4. 64 as 16 times 4. So I can take the 5th root, or the 4th root of 16, 6, make it look like a 6. I can take the 4th root of 16, and that's 2. 4 goes into 4 one time. So 4 is left. So 4th root of 16 is 2. 4 is stuck. 4 goes into 4 one time. 4 goes into y to the 6th one time with 2 left over. So this is 2xy, 4th root of 4y squared. Okay? And last one here. So 45 times 35, I'm going to show you a technique that'll work here. I'm going to put everything under the radical. Okay, I'm going to put everything under the same radical. You can multiply underneath with underneath. 45 times 35 is going to be a huge number, and then I got to go through my list and try to find something that'll divide into it. Here's something you can do that's better. Just break down 45. So 45 is 9. That's good. I can take that root. Okay. And then times 5. All right. And then 35 is 7. Can't do anything with that. Times 5. Okay. Well, this 5 times 5 is interesting to me because I can put that 5 times 5 together. 5 times 5 is 25. And I can take that root. So that's what I would do here, just to make everything a little bit easier. And then I have a total of 6 x's and a total of 7 y's. Okay, so what am I going to do to these two numbers that popped out? The root of 9 and the root of 25. We're going to multiply those. So 15 is out in front. 7, sorry, you're stuck underneath. 2 goes into 6 3 times, and 2 goes into 7 3 times with 1 remainder. So this answer is 15x cubed y cubed root 7y. All right, so that's pretty much, you know, just multiplying with radicals. Inside with inside, outside with outside. All right. Quotients, same thing. If they're under a like radical, you can write them as separate, or you can write them all underneath the same radical. Okay, so what you want to do here is make sure that you simplify first. Simplify first and then see what happens. So, for example, this one, you know, what you're going to end up doing here is rationalizing the denominator. So, for example, when you have 1 over root 2x, a fraction is not said to be simplified if there's a radical in the denominator. So you have to get the root out of this denominator. So when you first learn this in Algebra 1 or whatever, your teacher says, oh, just multiply denominator over denominator. Okay, just multiply denominator over denominator. And that's fine if you're dealing with a square root and a monomial. But that's the only time that kind of verbiage works. So when you multiply by denominator over denominator, first of all, you're multiplying by 1. Okay, so this is equal to 1. And you can always multiply by 1. It doesn't change the value. Okay, so that's legal to do because that's just 1. So you get root 2x up top. And what you're accomplishing here is root 2x times root 2x. You know, the 2 is squared, the x is squared, and so root 2x up top, you know, you've got square root of something squared. Well, that's just the number itself. Square root of something squared, well, that's just that variable itself. So by getting 2 of these into the problem, then you can square root and rationalize the denominator. Okay, so the same thing is what's going to happen with these larger indexes, these larger roots. But simplify first because you may not have to rationalize at all. So for example, here 2 goes into 50. They're both underneath the radical, so I can do the math. 2 goes into 50 25 times. And there's more x's on top by 2. So you don't even have to rationalize the denominator here. Once it gets simplified, that's just 5x. Same thing with this one. 4 goes into, there's a cube root. 4 goes into 96. So 4 goes into there twice. And 4 goes into 9 twice with 1 left over, that's 16. And then 4 goes into 16 4 times, so you know, we're just doing, you would have your calculator, so 96 divided by 4, you get 24. Okay. More x's up top by x, more y's on top by 4, and z to the 4th is just there. Okay, so I'm going to think of 24. My cube root list has an 8 in it, which is good. Okay, so I can take the cube root of 8. Let's see, we'll write this just right over here. That's going to be 2. Cube root of 8 is going to be 2. Where am I? X is stuck, so we'll get to that in just a minute. 3 goes into 4 one time, so 1y will be stuck. 3 goes into 4 one time, so 1z will be stuck. So this is 2yz, and then I have the cubed root of, gosh, I'm out of room here, 3xyz. A little rationalization got in the way there. Okay, so you end up with 2yz on the outside, cubed root of 3xyz on the inside. So hopefully you can see that okay. All right, last two, we are going to have to rationalize the denominator. Okay, but these are cube roots, so we want to think about what is actually happening here. All right, so I'm going to multiply by some form of 1, and I've got a cubed root. So how many 5s need to kind of negate, you know, negate a cubed root? I need 3 5s. Well, 5 is only 1 5. I mean, basically, I need this to be 125. So I can take the cubed root of 125, which is 5. Well, this is just 5. So I need 2 more 5s. So I'm going to be multiplying by 5 squared. So that's a total of 1, 2, 3, 5. So when I take the cubed root of it, it'll just be 5 itself. All right, and I've got 2 y's here, so I need just another y, so that this would be y cubed, and then I can take the cubed root of y cubed, which will just be y. So I have to multiply over itself, and here we go. So up top, just throw it all together. Okay, so this is 7 times 25. It's just 175. X and y. But look what we've done on the bottom. We get 5, 5, and 5. That's 5 cubed. Y, y, and y. That's y cubed. Okay? So that's just going to be cubed root of 175xy. Cubed root and the power of 3 just negate their inverses, and you're just left with the base. So that's 5y. And then our last one here. So clean it up first if you can. So let's do that. So I've got 5 over 12, 1x on top, y squared on bottom, and 1z on bottom. Okay, so 5 over 12, nothing I can do with that. An x on top, y squared on bottom, and a z, more z's on the bottom by 1. All right, so I'm going to need to, you could even split this, the radical, so it looks a little more familiar. So when I split it, I'm actually going to think about 12 as 4 times 3. 12 is 4 times 3. And 4 is 2 squared, and 3 is just 3. Okay? So I'm going to think of it this way so that I can know exactly what I need to, you know, bulk up the denominator with so that I can rationalize it and not have a root there. All right, so what do I need? I need 3 2's. I only have 2 2's, so I'm going to add another 2. I need 3 3's. I only have 1 3, so I'm going to do 3 squared. I need 3 y's. I have 2, so I need 1. I need 3 z's. I only have 1, so I'm going to do 2. All right, and that's because, sorry, I should have brought this down. That's a 3, that's a 3, and that's a 3. Okay, I want powers of 3 there so that when I take the cubed root of power over 3, I'll just get the base. Okay, so this is what I'm going to multiply over itself, and that's a cubed root. 2, 3 squared, y, z squared. All right, so pretty much out of room here. Let's see, I'm just going to grab a blank sheet of paper somewhere. Okay. Blank sheet of paper here. I'm just going to carry this on down here. All right, so okay, so here we are. So up top in the numerator, this is my extend the page, right? I'm not on Smartboard. I'm extended my page with a new piece of paper. Okay, so up top I've got 5, and then I've got 2, which is 10. I don't even need my calculator. And then so 3 squared, which is 9. So that's 90. It's going to be the cubed root of 90. Okay, cubed root of 90. And then I've got x and y and z squared. Okay, so that is what we have there, 90x, y, z squared. And then on the bottom, again, note I've got the cubed root of 3 2's, 3 3's, 3 y's, and 3 z's. So your final answer here is cubed root of 90x, y, z squared. These will just knock each other out, and this will just be 2 times 3, y cubed, z cubed. Okay? And then 2 times 3 is, of course, 6. All right. So this final answer is right here. Am I going to cancel 6 into 90 by 3's? No. Inside, outside. Am I going to cancel any y's here, any z's here? No. This is under the radical. This has been rationalized, so this is where the problem stops. All right, you guys, so that's 6.2. Hope this is helpful to you, and I'll look forward to seeing you guys in class. All right. See ya.